Welcome to qnawire.
To construct a confidence interval for the population mean with a given confidence level and sample size, we'll use the t-distribution since the population standard deviation is not known. And given that the sample mean is 109 and the standard deviation is 10, in A, the sample size is 14, and alpha is going to be 0.02 for a 98% confidence level, which means our critical T is well, it also means our degrees of freedom is 13. So that is a critical T of positive and negative 2.6503. And so our confidence interval is going to be our sample mean plus or minus our critical T. Here's what it is in general. So 109 plus or minus 2.6503 times 10 over the square root of 14. And we want this to one decimal place. The lower boundary is found by subtracting. And that's 101.9. And the upper boundary found by adding 116.1. For B, at 98% with a sample size of 24, that would mean degrees of freedom is 23. Alpha is still 0.02. Our critical T is now 2.5 basically. So our confidence interval is going to be 109 plus or minus 2.5 times 10 over the square root of 24. Lower boundary is 103.9. Upper boundary 114.1. For C, with a sample size of 14, degrees of freedom of 13, now alpha is 0.01 at 99%. Our critical T is now 3.0123. And so our confidence interval is 109 plus or minus 3.0123 times 10 over the square root of 14. Lower boundary is 100.9. And upper boundary 117.1. For part D, yes, we could have computed the confidence intervals even if the population had not been normally distributed, as long as the sample size is large enough due to the central limit theorem. So in such cases, the t-distribution is used instead of the standard normal distribution when the population standard deviation is not known.